Hello everyone, welcome to the lecture series of Engineering Mathematics 1. Today we are going to have our 7th lecture on partial differentiation. Okay, so let's see the next topic here in this 7th lecture, that is change of independent variable. Okay, so let's see what is a change of independent variable. See, you are having a function z is equal to f of xy. Means z is a function of xy. We can write here z, it is a function of which two variables? X and y. Okay. Where x is a function of uv and y is also a function of uv. Means your x and y, these are the functions of u and v. Okay, so from this we can derive a chain rule, as this is a composite function, right? So see here, if I want to differentiate z with respect to u, as you can see, z is not directly depending on u and v. So if I want to differentiate this z with respect to u, first of all, I have to differentiate this z with respect to x, then x with respect to u, plus z with respect to y, then y with respect to u. Okay? This chain rule we have to use here to find the derivative of z with respect to u. But you can see here, z is depending on xy and xy are depending on uv. Right? So here, z is depending on two variables and xy are also depending on two variables. Means there is a dependency more than one variable. Right? So what we have to do here? We have to use partial derivative. Okay? So you can see here in this chain rule, we have used all partial derivatives. Okay? So I hope you all understood what is a change of independent variable. Okay? We are changing the dependency here then. Now, let's solve the example on this. This is our first example where z is a function of xy, that is given to you. Z, it is a function of xy. Okay? And also you are given x is equal to e to the power u plus e to the power minus v. Y is equal to e to the power minus u minus e to the power v. Okay? Means your x and y are functions of u, v. Okay? And we have to prove here dou z by dou u minus dou z by dou v is equal to x into dou z by dou x minus y into dou z by dou y. Okay? So, this we have to prove. But according to the given part, this is actually the dependency. Right? So, from this I can derive a chain rule. So, whatever is the example given to you, you have to always write down the dependency and from that dependency write down the chain rule and then solve the example. Okay? So, see here, z is depending on xy and xy is depending on uv. So, if I want to find the derivative of z with respect to u, see, I have to use this chain rule. For z with respect to u, first of all we have to differentiate z with respect to x. So it is z with respect to x. All the derivatives are partial because there is dependency more than one variable. Okay. Then x with respect to u plus now z with respect to y and y with respect to u. Okay. So z with respect to y and y with respect to u. Right? Similarly, if I want to differentiate this z with respect to v, as we can see here, there is no direct dependency of z on v. So I have to go through this. I have to first differentiate z with respect to x and then x with respect to v plus z with respect to y, and then y with respect to v. That is actually the chain rule, right? Now we got here chain rule. So simply we can solve now this proof. If you observe your left hand side, okay, to prove that we are going to actually show left hand side is equal to right hand side. So to solve the left hand side, I just have to find these partial derivatives, and as you can see, by using this chain rule, I can find z with respect to u and z with respect to v. Okay. So to find first of all z with respect to u, I have to find all these 4 derivatives. So first of all here you have to write a given part. What is given to you? X is equal to e to the power u plus e to the power minus v. Y is equal to e to the power minus u minus e to the power v. Okay. So here, first of all, we are going to find all the derivatives of x. So differentiate x with respect to u, keeping v constant because x is a function of u and v. Okay. So when I differentiate this x with respect to u, this e to the power minus v is totally constant term. So its derivative will be 0. And I will have here derivative for this term e to the power u. Right? Now differentiate this x with respect to v. So here derivative of x with respect to v, then this derivative will be 0 because we are finding derivative with respect to v. So u is constant and taking a derivative of e to the power minus v. It is e to the power minus v into derivative of minus v, that is minus 1. Okay. Now similarly we have to differentiate y with respect to u and v. So first of all, differentiating y with respect to u, keeping v constant. So derivative of e to the power minus u, it is e to the power minus u into derivative of minus u, it is minus 1. Plus, if we find here derivative of this y with respect to u, then e to the power v is 0, right? Because it is a constant term. So derivative of e to the power v is 0, don't write here. Then find here derivative of y with respect to v, keeping u constant. So e to the power minus u is constant and derivative of minus e to the power v, it is minus e to the power v. So now from the given part, we have find all these derivatives. Okay. See here, we are also given z is a function of xy. But we are not given actually the value of z here in terms of xy. So whenever we differentiate z with respect to x or with respect to y, that derivatives will be remain as it is. We cannot put any value for that. Okay. Because we don't have a value for z in terms of x and y. So we have to keep these derivatives of z with respect to x and y as it is. Okay. So here, see, I can write, suppose this is your equation 1 and this is your equation 2. So from equation 1, z with respect to u is equal to, put your value for z with respect to x. As I told you, we don't have z in terms of xy. So we cannot find this derivative. We have to keep it as it is. Okay. Into x with respect to u. That we have find here. It is e to the power u. Plus, now z with respect to y. Write it as it is. And y with respect to u. So what is y with respect to u? You can see here, it is minus of e to the power minus u. Okay. So if I simplify this, what I can write here? Dou z by dou x e to the power u. This will be minus, plus into minus, it is minus. Dou z by dou y e to the power minus u. Okay. Now similarly, from equation 2, what I can write? Put the values here again. From equation 2, I will have a derivative of z with respect to v. So again, this derivative will be as it is, as we don't have a value of z in terms of xy, and x with respect to v, that we have find here, this one. So I can write here minus 1 into e to the power minus v, plus. Now z with respect to y, again we have to keep this as it is, and we have to replace the value of y with respect to v. What is y with respect to v here? Yes, you can see it is minus e to the power v, right? And so if I simplify this, what I get? Minus z with respect to x into e to the power minus v minus z with respect to y e to the power v. Okay. So here, now I got the value for z with respect to u, z with respect to v. So I can solve here this left hand side now. Okay. So consider here left hand side. What is the left hand side? It is z with respect to u minus z with respect to v. Right? Put here value of z with respect to u and z with respect to v. So what is the value here? See? Yes, this value we have to write. So it is e to the power u z with respect to x minus, then e to the power minus u z with respect to y minus a big curly bracket we have to write, because we have to multiply a minus sign to each term. Okay. So then if I write here the value for z with respect to v, what is the value? Yes, this one I have to write minus dou z by dou x into, it is e to the power minus v minus, see this one, dou z by dou y, right, into e to the power v. Okay. Now see here, we have written the values of dou z by dou u and dou z by dou v. Now simplify the term. So e to the power u dou z by dou x, this minus minus will be plus, e to the power minus v dou z by dou x minus this one, e to the power minus u dou z by dou y minus minus, this will be plus here, e to the power v dou z by dou y. Okay. So here from this I can find dou z by dou x common. So what is remaining? E to the power u plus e to the power minus v dou z by dou x minus, now here I have find minus sign common. Okay. So also I have find here dou z by dou y common. What is remaining then? E to the power minus u minus e to the power v dou z by dou y. But e to the power u plus e to the power minus v, it is a value of x here. You can see e to the power u plus e to the power minus v, that is x, and e to the power minus u minus e to the power v, that is y. So simply I can replace these values by x and y. So I can write here x into dou z by dou x minus y into dou z by dou y. Since we have a value for x it is e to the power u plus e to the power minus v, and y e to the power minus u minus e to the power v, right? And this is our what? Required right hand side, hence proved. Okay, so I hope you all understood the example here. So this is how we are going to solve the examples based on change of independent variable. Okay, always remember, first of all you have to write down all the dependencies. Using that dependency you have to write a chain rule and then solve the example. That will make your example easy. Okay, let's solve here one more example on the same type. Now this time, see here from the given part, always write down the dependency first. X is given to you VW, Y is given to you UW, and Z is given to you UV. So from these, what we can say? X, Y, Z. These three variables are depending on U, V, W. Three variables. Okay? And here, if you see, all these are the partial derivatives of which function? Phi. So here, we can write phi is depending on x, y, z. Say, that is our consideration. Because we can see here derivatives of phi with respect to x, y and z. Okay. So we make here chain rule. Phi with respect to x, y, z and x, y, z with respect to u, v, w. Okay. So if I want to find a derivative of phi with respect to u, then what will be the chain rule? See here. First of all, I have to find a derivative of phi with respect to x. Yes. Then derivative of x with respect to u. Okay. Plus derivative of phi with respect to y. Then derivative of y with respect to u. Plus derivative of phi with respect to z. Into derivative of z with respect to u. Okay, this is a chain rule. So similarly, we can write a chain rule for phi with respect to v. Okay, so write down here chain rule. Phi with respect to v, I can write phi with respect to x, then x with respect to v plus phi with respect to y, then y with respect to v plus phi with respect to z, z with respect to v. Okay, and third one, phi with respect to w. So what I can write here? Dou phi upon dou w. All these are partial derivatives because the dependency is on more than one variable. Okay. So here dou phi upon dou w, that I can write phi with respect to x, x with respect to w plus phi with respect to y, then y with respect to w plus phi with respect to z, and then z with respect to w. Right? So say this is equation 1, this is equation 2 and this is equation 3. Okay. Now from given part, we are going to find all these derivatives. So first of all, write down your given x is equal to root VW. Right? So here I can write this root V into root W. Okay. So first of all, solving for this x, I am going to differentiate x with respect to u. Okay. But there is no term of u. means total term with respect to u is now going to be constant. So when your term is constant, then its derivative is what? 0. Similarly, x with respect to v. So that time w becomes constant and derivative of this root v, yes, it is 1 upon 2 root v and root w is constant. Okay. Then derivative of x I have to find with respect to w. Now this time root v will be constant and I have to take a derivative of root w. What is it? 1 upon 2 root w. That is a differentiation. Okay. So similarly, as we find here all derivatives of x with respect to u v w, we have to find here all derivatives of y with respect to u v w and all derivatives of z with respect to u v w. Okay. Now, for y equal to, what is the value for y? Yes, it is root wu. Okay. So this also I can write root w into root u. We can separate a root. Now from this, what is the derivative of y with respect to u? Yes, here w is constant and we have a term for u. So I can write here root w into derivative of root u. It is 1 by 2 root u. Okay. Then derivative of y with respect to v. So what I can write here? Yes, here there is no term for v. So this complete term becomes constant and derivative of constant is what? 0. Okay. Now taking a derivative of y with respect to w. So while finding a derivative with respect to w, u is constant. So this time when I take a derivative of y with respect to w, your root u is constant and derivative of root w, it is 1 upon 2 root w. Okay. Similarly here for the third value, z equals to ub. Okay. So here for z equals to ub, what I can write? Yes, I can write root u into root v. Now finding all the derivatives of z, first of all find derivative of z with respect to u. So root v is constant and derivative of root u 1 upon 2 root u. Then derivative of z with respect to v. Now root u is constant and derivative of root v, it is 1 upon 2 root v. Okay. And last one, that is derivative of z with respect to w. Now there is no w. So the complete term becomes constant with respect to w and we have to write its derivative, that is 0. Okay. So I hope you all understood all these. Now we have to put all these partial derivatives here in equation 1, 2 and 3. That will give us these values of derivative of phi with respect to u, then phi with respect to v and phi with respect to w. Okay, so let's put all these values. So from equation 1, first of all, what I can get? See here, from equation 1, dou phi upon dou x is equals to, see, just a minute, dou phi upon dou u, we will get dou phi upon dou u, not x. So we have to just erase this. Okay, so it is dou phi upon dou u, right? Now what is dou phi upon dou u? Dou phi upon dou x into dou x by dou u. So we have to write here dou phi upon dou x. This derivative will be as it is because we don't have a function phi in terms of x, y, z. Okay. Now next, x with respect to u. What is x with respect to u? It is 0. So I can write here 0 plus. Then phi with respect to pi and y with respect to u. So here first of all write here phi with respect to y and y with respect to u. What is the derivative of y? Y, yes, this is y, and derivative of y with respect to u, this one, root w upon 2 root u. So I can write here root w upon 2 root u plus, now third term, dou phi upon dou z into dou z by dou u. So just write here dou phi upon dou z into dou z by dou u, means derivative of z with respect to u. This we have to write. Okay, so what is it? Yes, root v upon 2 root u. Okay, now we got here dou phi by dou u. Now to find dou phi upon dou v, we can write this from equation 2. This is our equation 2. So it is what? Dou phi by dou x by dou v. So I can write here dou phi by dou x and dou x by dou v. So what is the value for x with respect to v? You can see root w upon 2 root v. So we have to write it here root w upon 2 root v. Okay, then plus what is the value here? Yes, phi with respect to y, y with respect to v. So I can write here phi with respect to y and then y with respect to v. What is y with respect to v? It is 0. So just simply write here 0 plus third one, phi with respect to z, z with respect to v. So I can write here phi with respect to z, and what is the z with respect to v? Here it is, right? So I can write it is root u upon 2 root v. Okay, so I hope you understood. Now the last value we have to write, that is dou phi by dou w. So what I get here from equation 3, dou phi by dou w is equal to, yes, phi with respect to x, x with respect to w. Phi with respect to x. So x with respect to w here. This is the value, this we have to write. It is what? Root v upon 2 root w plus. Next one is what? Phi with respect to y, y with respect to w. So here I can write phi with respect to y and y with respect to w. What is y with respect to w? This one. So I can write here root u upon 2 root w plus, definitely last one is phi with respect to z. And what is z with respect to w? It is 0. So I can write here it is 0. Okay. Okay. So here we got all these 3 derivatives. Let's solve this. What is this then? Dou phi by dou u. First term is 0. So these 2 terms are only remaining there. So I can write phi with respect to y root w upon 2 root u plus phi with respect to z, then root v upon 2 root u. Okay, that is equal to phi with respect to x root w upon 2 root v plus phi with respect to z root u upon 2 root v, and this will be phi with respect to x root v upon 2 root w plus phi with respect to y root u upon 2 root w. Right? So here see, I can use all these 3 partial derivatives in this right hand side that we have to prove. So we can solve your right hand side. So right hand side is equals to, it is u into dou phi upon dou u plus v into dou phi upon dou v plus W into dou phi upon dou W, right? So if I multiply here dou phi by dou U by U, means this is your value for dou phi by dou U. Okay, so I have to multiply here by U. So when I multiply this term by U upon root U, means here root U cancel and remaining is what? Only root U, right? So I can write this. So then the term will be, I can write 1 by 2 root UW, multiply U of phi with respect to U by U. Okay, so here that is then phi with respect to Y plus multiply here again by U, that will give you 1 by 2 root VU phi with respect to Z plus, now for this term I have to multiply phi with respect to V by V. This is your value for phi with respect to V, and here we are going to multiply by V. So what is remaining then? 1 by 2 root VW, yes, phi with respect to X plus 1 by 2 root this term multiply by V, so that will be UV phi with respect to Z plus, now the last term dou phi by dou W, this is dou phi by dou W and we have to multiply it by W. So if I multiply here by W, what I will get? Yes, it is 1 by 2 root VW phi with respect to X plus 1 by 2 root UW phi with respect to X. Phi with respect to Y, not X. Okay. So here, if we check, this is your phi with respect to X, phi with respect to X, and both the terms are same. So simply we have to do addition. So can I write here right hand side is equals to, see, if I do the addition of these two terms, 1 by 2 plus 1 by 2, that will be 2 by 2, means only 1 is remaining. So I can write this is, I can write C root VW dou phi by dou X, dou phi upon dou X plus, now see, for this dou phi upon dou Y and dou phi upon dou Y, both the terms are same. So simply we have to add this. So 1 by 2 plus 1 by 2 again 1. So I can write here root UW phi with respect to Y plus, now remaining is only dou phi by dou Z, and this term is also same. So I can write here after doing addition root VU dou phi upon dou Z. Okay, and simply you can see these are the values of X, Y, Z that is in given part. Okay, so I can replace this by X dou phi by dou X plus Y dou phi by dou Y plus Z dou phi by dou Z, and this is what our required left hand side. You can check here, see, this is your required left hand side that we have proved, hence proved. Okay, so I hope you all understood what is change of independent variable and how to solve examples based on it. Okay, let's solve one more example on the same type. So here Z is a function of xy. As I told you, you have to first write down the dependency. Okay, and xy that are in terms of u and v. So dependency of xy is on uv, right? So I got the dependency. So I can derive a chain rule from this dependency. So if I want to find a derivative of z with respect to u. Now see, there are more than one variable. Dependency is on more than one variable. So definitely when I take a derivative, it should be partial derivative. Okay. So then z with respect to u is equals to, okay, I can't directly find a derivative, so I have to first find z with respect to x, then x with respect to u, right? Z with respect to x, then x with respect to u, plus now z with respect to y and y with respect to u. Okay, say this is equation 1. Similarly here now we have to find z with respect to v also. So again using a chain rule, change the dependency, z with respect to x, x with respect to v, plus z with respect to y, and then y with respect to v. Say this is your equation 2. Okay, now by using these two equations I can find the values of z with respect to u and z with respect to v. Right, now see here, they are saying z is a function of xy. So instead of this z, I can write here f also. Okay, so I mean to say here I can write this one as y into dou z by dou u plus x into dou z by dou v is equal to e to the power 2u dou z by dou y. This also I can write because it is given z is a function of xy, f of xy. So instead of z we can use notation f also. Okay. So first of all, finding these derivatives, partial derivatives, we have to use a given part. First of all, given is one value first we are going to use, that is x equal to e to the power u cos v. Differentiate this x with respect to u keeping v constant. What is its derivative? See, x with respect to u keeping v constant means cos v constant, and derivative of e to the power u, it is e to the power u. Okay. Then differentiate this x with respect to v keeping u constant. This time e to the power u is constant, and derivative of cos v, it is minus sin v. Okay. Now we have a second value for y. What is it? E to the power u, this should be u, into sin v. Okay, this is u, not v. So e to the power u into sin v. Differentiate this y with respect to u. Definitely e to the power u derivative and sin v constant. Okay, and y with respect to v. This time e to the power u is constant and derivative of sin v, it is cos v. Okay. Now using all these derivatives here in equation 1 and 2, we will get the value for z with respect to u and z with respect to v. Okay. So from equation 1, I can write from equation 1, what I can write? See here, z with respect to u. Okay. So can write z with respect to u is equals to, yes, what is it? So here I can write z with respect to u, z with respect to x. So here z with respect to x, okay, then x with respect to u. What is x with respect to u? Here it is. Okay, that value we have to put e to the power u cos v plus, now see, Z with respect to y, y with respect to u. So first of all write here z with respect to y and then y with respect to u. This is your y with respect to u. So I can write here e to the power u sin v. Okay. But your z with respect to u means this f with respect to u. It is multiplied by y. Okay. So I have to multiply here by y. So multiply by y. What I get? Y into dou z by dou u is equal to y. What is the value for y here? E to the power sin v. Right? So y into dou z by dou x into e to the power u cos v plus y into dou z by dou y e to the power u into sin v. Right? So putting here value for y. What is the value for y? Yes, it is e to the power v sin v. So if I put here y is equal to e to the power v sin v on right hand side only, okay, I will get here e to the power 2u sin v cos v dou z by dou x plus here also put the value for y. What I will get? Yes, e to the power 2u sin v into sin v. It is sin square v dou z by dou y. Okay. Similarly, now using equation 2. From equation 2, what I can write? Yes, I can write a derivative of z with respect to v. So here, z with respect to v is equals to, you can see z with respect to x and then x with respect to v. So here it is z with respect to x and x with respect to v. What is it? This. I have to put this value here. So it is e to the power u minus sin v plus now z with respect to y and y with respect to v. So I can write here z with respect to y and what is the value for y with respect to v? This one. I have to write this. So it is e to the power u cos v. Okay. But now here this dou z by dou v, this is multiplied by x. Right? In our proof. So I have to multiply here by x. Multiply by x. So what I get? X into dou z by dou v is equal to x into dou z by dou x into e to the power u minus sin v plus x into dou z by dou y e to the power u cos v. Okay. Now next is what? Yes, simplify the term. So what I will get here? Put the value for x. What is the value for x? E to the power u cos v. So see here. This will become e to the power 2u cos v sin v. But this is a negative term. So this will be minus here z with respect to x plus if I put here x is equal to this value e to the power u cos v. What it will be? E to the power 2u cos v into cos v cos square v dou z by dou y. Okay. Now see, let's say this is our equation A and this is our equation B. So from equation A and B, now I can solve this left hand side. So consider left hand side here, that is y into dou f upon dou u plus x into dou f upon dou v. But f means what? Z. So what is the value for y into dou f upon dou u? This one, equation B. Sorry, this one, equation A. And what is the value for x into dou f by dou v? This equation B. So if I add this equation A and equation B, what happens? these term and these term both are same but having opposite sign will get cancelled. So what is remaining? Addition of these two I will get. E to the power 2u is common here. Also dou z by dou y is common here. And what is remaining then? It is sine square v plus here what is remaining? Cos square v. After finding e to the power 2u dou z by dou y common. Right? We are adding these two equations. Okay. And so here, what is the value for cos square theta plus sin square theta? It is one fundamental result. Right? So I can write here only e to the power 2u dou z by dou y. That is, we can write, hence proved. That is our required proof for the example. So I hope you understood the example that we have taken today here. Let's solve one more example of same kind. Now see in this example what is a given part. Okay. So x plus y is equal to 2 e to the power theta cos phi and x minus y is equal to 2 root minus 1 e to the power theta sin phi. These are the given functions. Okay. But we have to find the derivative of v with respect to theta and with respect to phi. Right? So what I can write? First of all, I have to find a value for x only and then value for y only. So here, if I do the addition of these two equations, first of all write down the given part. It is x plus y is equal to 2 e to the power theta cos phi and x minus y is equals to 2 root minus 1 e to the power theta sin phi. Right? But before that, let me simplify the term. Okay? This is root minus 1. And we can write a value for root minus 1, that is I. Because I square is minus 1. So value for I is root minus 1. So this term is as it is. There is no correction. Okay. But here instead of this root minus 1, I am going to write 2i e to the power theta sin phi. Since root of minus 1 is equal to I. Now see, if we add these two equations together, say this is equation 1 and this is equation 2. So if I add these two equations together, y will get cancelled. I'll get here 2x, that is equal to this here. If we add, see, 2 e to the power theta, 2 e to the power theta. This is common. And what is remaining? Yes, cos phi plus I sin phi. This is a remaining term. Okay. That is equal to 2 e to the power theta into. Now we all know here e to the power I theta, we can write cos theta plus I sin theta. Okay. So I can write this cos phi plus I sin phi e to the power I phi. Means it is 2 e to the power theta plus I phi. Right? So this is your value for x. 2 to get cancelled. E to the power theta plus I phi. Right? Now similarly I have to find a value for y. So this time I am now going to subtract the equation. Okay. So subtracting the equation, I will get 2y is equal to, again 2 e to the power theta common. And this time there will be subtraction. Okay. So let me tell you, when there is a minus sign, then this power is also here negative. Okay. And then 2 e to the power theta minus I phi. So again here 2 to get cancelled. What is your value for y? E to the power theta minus I phi. Okay. So here you got, say this is our equation A and this is our equation B. You got the value for x and y. Now I can find this derivative of v with respect to theta and phi. See, x and y from this equation a and b, we can say they are depending on theta and phi. Okay, so I can write v is depending on xy. Now using here chain rule, v with respect to theta, I can write v with respect to x, x with respect to theta, plus v with respect to y, y with respect to theta. Okay, and then v with respect to phi, what we can write? Yes, v with respect to x, x with respect to phi, plus v with respect to y, y with respect to phi. See, this is equation A and this is equation B. So we have to solve these two equations. We have to put all partial derivatives here in equation A and B. And we can find all that partial derivatives by using the values of x and y. So now, here, x is what? E to the power theta plus I phi. So what is the derivative of x with respect to theta? Yes, it is e to the power theta plus I phi. And what is the derivative of x with respect to phi? Definitely, it is e to the power theta plus I phi. But again, derivative of this theta plus I phi with respect to phi, it is I. Okay. Similarly, for y, e to the power theta minus I phi. So this will give me y with respect to theta, that is e to the power theta minus I phi, and y with respect to phi, that will be e to the power theta minus I phi, and derivative of this power with respect to phi, it is minus I. Okay. So here these are the four partial derivatives. Using these partial derivatives here in equation A and B. So first of all, write from equation A, I'll get v with respect to theta. So v with respect to theta is equals to what? Yes, dou v by dou x, right? So I can write here, as we don't have value of v in terms of x and y, so I have to write this value as it is. Okay. And then x with respect to theta. What is our x with respect to theta? Yes, you can see here this term, e to the power theta plus I phi. Okay. Then plus here v with respect to theta, right? So I can write here v with respect to just a minute, v with respect to y and y with respect to theta. So v with respect to y, and what is the value for y with respect to theta? Here it is, y with respect to theta. I can write e to the power theta minus I phi. Okay. But this is only the first order derivative I got here. And we are having a second order derivative. Okay. So see here, if I cancel this v, from this I can write the value for the differential operator dou by dou theta. What is it? Dou by dou x e to the power theta plus I phi. Okay. Plus e to the power theta minus I phi dou by dou y. Just we have cancelled this term for v. Okay. Now, again differentiating dou v by dou theta by theta. So this will give you dou to v upon dou theta square, double derivative of v with respect to theta, right? So that I can write here dou by dou theta upon dou v by dou theta. It is a meaning, right, for the double derivative. But what is the value for this differential operator? This one that we have find. See here, e to the power theta plus I phi dou by dou x plus e to the power theta minus I phi dou by dou y. Okay, into dou v by dou theta. This value. Write down e to the power theta plus I phi dou v by dou x plus e to the power theta minus I phi dou v by dou y. And just we have to open these brackets here. Okay, so when we open the bracket, what term we get here? See, this term into t's term means again double derivative of v with respect to x. So here what I will get? Just a minute. Yes, that is dou 2v upon dou theta square is equals to, okay, I'll get here e to the power 2 in bracket theta plus I phi into dou 2v upon dou x square, right? Then what I will get here? Plus 2, yes, e to the power theta plus I phi into e to the power theta minus I phi, right? So I'll get here 2 e to the power 2 theta dou 2v upon dou x dou y plus e to the power, now this term, 2 theta minus I phi dou 2v upon dou y square. Okay, that is a value for dou 2v upon dou theta square. Now similarly I have to find dou 2v upon dou y square. So here from b I can write dou v by dou phi. See, from b, here it is b, just we have to put the values of x and y with respect to phi. So here it is v with respect to x and x with respect to phi. What is x with respect to phi? This one. So I can write here I into e to the power theta plus I phi plus v with respect to y. What is the value for y with respect to phi? This one. So I can write it is minus I e to the power theta minus I phi. Okay. Now simplify the term here. So from this I can write a value for differential operator dou by dou phi is equals to I common I can write. Okay. So that is e to the power theta plus I phi into dou by dou x minus I e to the power theta minus I phi dou by dou y, right? So therefore similarly if I differentiate this term with respect to phi again, that will give me double derivative. So this I can write dou by dou phi into dou v upon dou phi, that is equals to what we can write? Value for dou by dou phi. This we have right here. Okay. So if I take here I common, that is what? E to the power theta plus I phi dou by dou x minus e to the power theta minus I phi dou by dou y. Okay. Into v with respect to phi. Here also I can find I common. So I can write here I e to the power theta plus I phi dou v by dou x minus, yes, it is what? E to the power theta minus I phi dou v upon dou y. Okay, just we have put the values of dou by dou phi and dou v by dou phi here. And now open the brackets. So I into I, that is I square, and I square, that is what? Minus. And if I solve this bracket, if I multiply together, I'll get here e to the power 2 theta plus I phi into dou 2v upon dou x square. Then both the terms are negative, so this will be minus 2 e to the power 2 theta into dou 2v upon dou x dou y plus this into this, that is going to be plus, I can write here e to the power 2 theta minus I phi, okay, dou 2v upon dou y square. Okay, so I hope you all understand. Now see here, I got these two values, I can add this together. So now I can solve the left hand side. So what is the left hand side? Dou 2v upon dou theta square plus dou 2v upon dou phi square, right? So if I put the values of dou 2v upon dou theta square and dou 2v upon dou phi square, see which terms are going to cancel. Just we have to do addition. So if you check here, dou 2v upon dou theta square, first term, this and this term, if we do addition, this is negative, so which it is going to be cancelled, right? Then this term and this term both are same, but minus minus, this is going to be plus, so there will be the addition for this 4 e to the power 2 theta dou 2v upon dou x dou y, and this last term and this last term, as you can see there is a negative sign, so this will be negative, and opposite signs but terms are same, so both terms are going to cancel here, right? So this is our answer, but in our final answer there is 4xy. So here e to the power 2 theta, so we know that x is equal to e to the power theta plus I phi, and y is equal to e to the power theta minus I phi. And if I take a product of these two, right, there will be the power of addition, addition of the powers, because base is same, e, right? So plus I phi and minus I phi will cancel, the term will be e to the power 2 theta. So I can replace this e to the power 2 theta by xy. So here I am going to write it is 4xy dou 2v upon dou x dou y, that is our required right hand side, and here we can say hence proved. Okay, so I hope you all understand all these examples that I have taken today on change of independent variable. Okay, thank you all for watching this video. In next video we are going to see some more examples of the same type.